Hello everyone. In this video we're going to be solving an interesting differential equation. We have y prime equals x minus y divided by x plus 2y. So y prime is the first derivative of y with respect to x, and it's equal to this fraction. So I'll be presenting two methods, even though the first method will be incomplete. Alright, let's get started. For my first method, I'm going to use the following technique. Since we kind of have like a ratio, we can kind of talk about the ratio of y to x or x to y in a problem like this, because if you divide everything by y, you will get kind of like a function of x over y. Or if you divide everything by x, then you'll get y over x. So let's go ahead and do the following. Let's call y over x something. How about u? So since y is a function of x, x is a function of x, u is also going to be a function of x. So from here we get, as long as x does not equal 0, we get y equals ux. So that's going to be what we're going to use. Basically, we're going to be using substitution here. Let's go ahead and plug this into the equation. But before that, we need to evaluate y prime. So since this is like a product and y is equal to ux, they're both functions of x, we need to differentiate this product with respect to x. And to differentiate a product, you need to remember the product rule, the derivative of the first function, which is u prime, multiplied by the second function, plus the derivative of the second function, which is the derivative of x. In this case, that will be 1, because dx over dx is 1, right? The derivative of x with respect to x, times the first function u. So this is the same thing as x u prime plus u. So that's y prime. We can go ahead and replace y prime with that, which is x u prime plus u, and replace y with ux everywhere. Let's do it. X minus ux divided by x plus 2ux. So it's your birthday. Happy birthday to you. Okay. So here again, if x does not equal 0, we can go ahead and factor it out and cancel it. So x times 1 minus u divided by x times 1 plus 2u. X cancels out. We end up with this. Let's go ahead and subtract u from both sides. So we get x u prime equals 1 minus u divided by 1 plus 2u minus u. So I subtract u from both sides. And now we should be able to get something in terms of u here. So let's go ahead and make a common denominator. And that can be done by putting a 1 here and then multiplying the top and the bottom by, let's multiply the top and the bottom by, okay, I'm trying to change the color here. Give me a minute. Okay, I don't know why it keeps switching. Okay, here we go. So now we're gonna go ahead and make a common denominator, multiply u over 1 by 1 plus 2u here and here. So then you're gonna get x times u prime equals 1 minus u minus 2u squared divided by 1 plus 2u. Okay, great. Let's go ahead and do the following now. U prime is the derivative of u with respect to x. So we can write it as du over dx by using the d notation. And that's helpful if you're going to end up with a separable differential equation, which is what this is, then this is going to be very helpful. So let's go ahead and simplify the top and write it as a quadratic in simplest form or standard form, and then arrange the bottom as well. So everything is in standard form. Standard form means from highest power to lowest power. Now we have a du on the left and an expression of function of u on the right. So let's put those together. Let's multiply both sides by the reciprocal of this fraction right here. And that's going to give us the following. And of course, at the same time, we need to divide by x and multiply by dx. In other words, we can go ahead and do the following. First, multiply both sides by dx. So that expression is going to come times dx. And then we're going to divide by x, right? and divide by that expression. So our expression is going to go down here. To divide, we kind of need to multiply by the reciprocal. So the reciprocal of this expression is going to be 2u plus 1 divided by negative 2u squared minus 2u plus 1. So that's going to be our expression on the left times du equals dx over x. This is what we have here, right? Dx over x. Awesome. Now, this is a separable differential equation, already separated. So we can go ahead and integrate both sides, and that should give you the answer. But here's the thing, that should give you, all right, great. So you're going to get the answer as a function of u, but the problem is you have to do partial fractions here, so on and so forth. That's a lot of work, and it's going to, you know, save a lot of time. It's going to save us a lot of time if you skip this part and you do it on your own. But that's the whole idea. And once you find u in terms of x, of course, the right-hand side is just going to be ln x, and then you can put a constant here. So, and then you can do e to the power both sides, and that should give you at least x in terms of u. But then you can go ahead and back substitute because u is just y over x. So there's some work to be done there, but let's go ahead and talk about the second method, because second method is much nicer. All right, let's take a look. And this is just an alternative for these kinds of problems. Is this method, the second method, always going to work? That's for you to find out. All right, anyways, let me rewrite the original problem. Y prime is equal to x minus y divided by x plus 2y. For this scenario, I'm just going to assume that x plus 2y does not equal 0, and that already has to happen because we don't want 0 at the bottom. So under those conditions, I can go ahead and multiply both sides by x plus 2y. Let's do it. X plus 2y multiplied by y prime equals x minus y. Great. Now let's go ahead and put it together and see what we get from here, right? And I can basically distribute what's on the left-hand side and then put it all together. So we're going to get xy prime plus 2yy prime plus y minus x equals 0. So we put everything on the same side. Here's what I want you to notice. Now this expression may kind of seem meaningless to you because it's kind of like a jumbo mambo, but if you think really carefully about it, you're going to notice a couple things here. Let's go ahead and mention them real quick. First of all, I want to bring these two things together. I'll tell you why. xy prime plus y. And then plus 2yy prime minus x equals 0. So I want you to take a look at xy prime plus y. And this should remind you something. Okay? And what should it remind you? Good question, right? Well, if you think about this, this is the derivative of y times x, and then the derivative of x times y. Because the derivative of x is 1, I can actually insert a 1 here, which can be written as the derivative of x. So what does that tell you? What does that look like? Doesn't that look like the derivative of xy? And yes, that is exactly the derivative of the product. So we kind of use the product rule in the reverse order. And this guy over here is going to be the derivative of y squared. And why is that happening? Because if you differentiate y squared, you're going to move the y to the front. So kind of think about it this way. The 2y is the derivative of y squared, but from chain rule, we also have to multiply by y prime. That's why this is exactly the derivative of y squared, and then x is the derivative of x squared over 2. In other words, we integrated everything, and this is what we got. But this is just the derivative of a sum, because we can write the whole thing differentiated equals 0, but that just means that the whole expression must be a constant because the derivative of a constant is 0. And this is going to give you the solutions. But if you really need y in terms of x, good luck with that. You can solve this as a quadratic in y and get the y values. There's going to be 2 of them. And for the previous method, there's also going to be 2 answers with the plus, minus, or the absolute value. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.